Right, so we're gonna do a really quick um, tutorial on how to design a harness from a block diagram and how to use the software called Tinycad to draw the harness schematic. So as an example, I'm gonna use the Eclipse maiden block diagram, and I'm gonna design a harness on the left wing. So here we have I'm gonna design the section where we have the 5-volt CAN coming from the single servo driver to the pitote tube and the GPS. So the first thing we want to do is to identify the connectors on all ends of the harness. So for this harness on the single servo driver, we have a JST GH port. So we are gonna write it down really quick in Tinycad. So we're gonna click on text, and then this connector would be a JST GH 4-pin connector. This is on the single servo driver side. And then going back to the block diagram, we see that this CAN bus is connecting to the pitote tube and the GPS. So we go to the fixed wing electrical component sections, and we see the link for the pitote tube, which is wrong. The pitote tube is drawn. This is the correct one that we bought. So I'm gonna update the page later, but this is the one we bought. And we can see that it also uses a JST GH cable, and it has the same pin configuration as the single servo driver. So it has pin 1 is 5 volts, pin 2 is CAN high, pin 3 is CAN low, and pin 4 is ground. So same pin out, same configuration. So let's just write that down as well. So again, click on text, and then we can just paste this one actually. Copy paste. Okay, Tinycad is laggy. Get out of here. Oh, come on. What are you doing, Windows? Okay, this is why I hate Windows. But here we go. Okay, that's not what I want to do. So we're gonna copy that and put it around at the top. And now we are gonna look up we're going back to the block diagram right here, and we're gonna look up this GPS. So for the GPS, we're using the drone CAN GPS. We open up the link, and where did it go? Got out of here. Okay, right here, port type GHR04V-S. So now we can search up what this connector is. It's the same connector, JST GH. So that makes us life a lot easier. So we can copy this this text and then paste it somewhere down here as well. Alright, now we know all the connectors. We can now start drawing the harness. So the first thing I usually do is to draw out a box that represents the connector housing. So to follow the standards right here in the wiring harness standards, we have the connector name that we already put down, And now we just need to find the connector part number, which we also found just a couple seconds ago. So, oops, doesn't let me paste the text. Alright, so now we have the part number. So I'm gonna zoom in and place it right underneath. So so I'm gonna copy the text again, put it under the connector name one more time. Alright. Now we're gonna use the rectangle tool to quickly draw a rectangle represents the connectors. So 1, 2. Actually, you know what? I'm just gonna draw one rectangle and copy paste it to the other sides. So for since they're all using this GST 4-pin connector and they all have the same pinouts, actually for the drone can, to check its pinout, we can go to the Holy Bros documentation page. So here we just search drone can GPS. Okay, I don't want to ask this AI, but I just want to see the documentation. Well, alright, drone can GPS, drone can. Yes, right here. You can see it has a pinout section right here. So we confirm that it also has the same pinout as the two other GST connector, 5 volts, can high, can low, and ground. Yes, same deal. So now we know that their pinouts the same. We can just create one connector box and then copy this connector to the other two devices. So to add a pin, we're gonna use this label tool. So for 5 volts, I'll say it's an output from the single servo driver, and I'm just gonna label it as 5 volts and put it right there. And then we have can high, so can dash high, just type can dash high. And since this is a CAN bus, I'm gonna change it to IO. It doesn't matter that much for harness purposes. And we also have can low. And last, we have ground. Alright, and now we have the connector housing done. I'm just gonna copy that part and then paste it right here. So what I did, I just pressed R to rotate this this box. So right now this one would be an input and it will be pointing to the left. And then just gonna switch the order of the connectors so that can high is on top and then can low and then ground. Alright, that's good. Okay, and then copy paste it for the GP. Either way, they are the same thing. So right now we can wire up the connections. So in order to wire it up, I'm gonna use the wire tool. Very simple. I'm not gonna change it to 45 degrees. You'll see why in a sec. So now I'm just gonna wire this up to 5 volts. So roughly here, roughly there. Okay, just let me go up one grid. Alright, what's going on? Okay, there we go. And then wire up this 5 volts and done. And now for the cam high, we are gonna use for the CAN bus is a differential pair, so therefore we want to use twisted pair. We want to use twist the CAN high and the CAN low together. So we're gonna use this double X configuration as a twisted pair. So I just draw one down 45 degrees or 135 degrees, depends on how you see it. So draw the double X. Around here. And then I'm gonna draw double X again, just to be clear, very clear that this is a twisted pair. And same thing for CAN low. I'm gonna draw it like that. Okay, same thing on the other one. I'm gonna draw a twisted pair like that. And CAN high, go on to the CAN high bus. And then to place a junction, you just put the junction tool. That means the wires are shorted together. So right there, and I'll do a junction there for CAN low. So similarly, I want to do the twisted pair, you draw a double X like that. And then lastly for ground. So same thing, just wire it up. Very simple, very straightforward. And then for the junction, oops, wrong one. Okay, stop. How do I Control Z? Okay, I'm on Windows, so I have to use Control. Alright, and then, okay, now we are good. And then I'm gonna go back to the harness standards and see, oh, we need to label the pin numbers on the connectors. So we already know that we can double check from the single servo driver schematic. Pin 1 is 5 volts, pin 2 is CAN high, pin 3 is CAN low, and pin 4 is ground. So we go back to the Tinycad, so go click on text, just say 1, and then it will automatically increase it for you to 2, 3, and 4. And same thing on the other side. 1, 2, 3, 4, and then repeat. 1, 2, 3, and 4. Alright, and then double check. Now we need to label the wire gauge, color, and the length of the wire, just so that it's really clear when people are assembling the harness in person, they know how long and what wire to cut. So to do that, we also use the text tool, and for the CAN wires, since it draws very little current, we are going to use a 28 gauge wire. So this wire will be very thin, but it saves us weight. So we're going to use a 28 gauge, and for power we use red. And usually you don't know the length when you're designing a harness, so we can just put a question mark for the people in person at the work session to figure this out. So you can put 28 gauge red, and then repeat, and this will be the same. We're just gonna repeat this for the, oops, I forgot I cannot paste text in Tinycad. Okay, so after this junction means that the wires is gonna be split, and you see that this junction has 3 connections. So that means there will be 3 wires connected to this junction, and the person making this harness will need to solder 3 wires together. So for each wire is recommended to have their own characteristic labeled. So we're gonna put the same. We're gonna use the same wire. So we're gonna use 28 gauge red for all of them. Okay. Right there. And now for the CAN bus differential pair, we are gonna follow the PixHawk's standards for this one. So now we go to PixHawk's documentation from the wire and harness page and see for the CAN cables, they want 5 volts to be red, which we're already doing. And then they say CAN high can be white and CAN low can be yellow. So we're gonna use that. We can use white for CAN high. So let me drink some water. So we're gonna use the 3-letter abbreviation for white and just put it right here. Since I noticed that we don't have enough length, I'm just gonna drag this box a little bit to the left. Okay, so now they're nicely all aligned. Just drag it out a little bit more. Okay, looks much better now. White, and then for yellow, oh, by the way, you can check all the color codes right here, also in the harness standards conference page. So white is WHT, yellow here is YLW. So we are gonna use 28 gauge, yellow, YLW, and then leave the length as blank or question mark. And then lastly, we have the ground wire, which is gonna be black. So now, let me just see if I can copy this text. Okay, great. So I'm just gonna delete these wires really quick. Copy this text only. Got this out of here. So gonna drag them out a little bit as well. Drag this out as well. So, okay, just put it right there. Another one right here. Okay. Now we save this document. We can just name it Eclipse left wing harness, left wing CAN harness. So now let's just double check if you're missing anything. So we have the connector names, we have the connector part number, all labeled, and then we also have the pin numbers, pin names. Yes, we do. And we have the wire characteristics on the harness design as well. So now we are done. That's it for this harness. And the last step is to save this to GitHub, to WARG's GitHub repo. And to do that, I have to quit. Wait, actually, one last thing. If you want to sign your name, and okay, let me just zoom out a little bit. If you want to sign your name and take responsibilities. So you can do that. Just go to File and then Design Details. So you can say Eclipse left wing can harness, and author Jerry, organization WARG, and the today's date is 2025 January 30th. Wow. Alright, and now our harness is done. We can quit Tinycad. Let me just copy that to my desktop. So now I'm gonna open up GitHub desktop, and then right here I'm gonna go to WARG. We're gonna store it in the hardware repo. So I'm gonna open this folder right here. So in harness, we're gonna create a new folder. I'm gonna create a new folder called Eclipse. And then since this one is on the left wing, so I'm gonna create another folder for left wing. Actually, I'm gonna create all the folders. Left wing, right wing, fuselage. You don't need to do this. I'm just creating folders so that you know where to save your harness design files. Last one is tail. Okay, now we're gonna drag our latest fresh harness design into the left wing hub folder. So, oops. Alright, there we go. So now, after that, we are gonna write a GitHub commit message. So I'm say designed left wing can harness, and then commit push, and that's it. Thank you for listening, guys.